This is number 9 off of worksheet 104. What this is really playing off of is all those angle relationships that are created when we have parallel lines cut by a transversal. So from the diagram, here's what we have. Two parallel lines. You can tell they're parallel by these little arrow symbols here. Because those are parallel, we've got a bunch of different scenarios playing out. So the one that's relevant here is, let me use a different color. Here is one transversal that crosses through these two parallel lines. And so if I look at this one transversal, and I just kind of cover up these two, I don't look at those. This guy and this guy are on the same side of that transversal, and they're on the interior of the parallel line. So these are same side interior. Therefore, I can write this relationship. I can add those up, and I know that they're going to add up to 180 degrees. And again, I want to list a reason. Why can I say that? Because they're same side interior, and I know that when the scenario presents itself, the same side interiors are supplementary. Okay? Same thing here, same deal. We've got a different transversal down here, so we treat it as a completely different scenario. All right? We've still got the two red lines are parallel, but now we've got this blue transversal, and within that blue transversal, we've got two angles that are same side of the transversal, and they're on the interior of the parallel. So you just have to be careful about what two angles you relate to one another. Use that definition wisely. So here I would have 15x plus 4y plus 72. So the sum of these two angles are going to equal 180. In other words, they are supplementary, and they're supplementary because they are same side interior. Make sure you guys list these reasons here. That's the most important part in this geometry class. After this, it's really just system of equations. So what we want to do is we want to eliminate one equation. We can simplify this down a little bit by moving this 80 over and this 72 over. So I can simplify this into this, and the bottom equation into this. $108. Okay. From there, you're probably going to want to do elimination method. So elimination method, because we have a system of equations. So I need to get one of these variables out of here. The variable I'm choosing to get out of here is the y. So I want to cancel this. I want my y's to cancel. I'm going to multiply by my equation down here by -5, my equation up here by 4. That way they have opposite signs. And we're going to combine these two. So I'm now going to have 40x in the numerator plus 20y equals 400. I'm sorry, not the numerator, for the top equation. The bottom equation, we're going to end up with -75x minus 20, and that's what we wanted because these are now going to drop off. That's equal to -540. All right, we're going to combine these two. I get a -35x equals -140, and divide by -35, and you end up with x equals +4. There's one of my answers. Plug that back up into the numerator. I'm sorry, not the numerator, one of these equations up here. I can plug it into either one is fine. I'm going to plug it into this green equation here, so I'm going to have 10 times 4 plus 5y plus 80 equals 180. And when I plug that in, I get 40 here and 80, that's 120. So 5y plus 120 equals 180. Move that over, divide by 5. I'll let you guys do the math on that. And that's going to give me 12. So there is my answer. X is 4, y is 12. That ordered pair is the solution to this particular scenario.